today we'll start the new topics, derivative of the inverse function. But before that, some definitions, some pre-knowledge. That is, inverse function means what? Let function f is defined from a to b is 1 1 and on to. Again, what is meant by the 1 1? 1 1 means what? That is a different element in a has a different images in b. Then the given function is called the 1 1. And what is meant by the onto? Onto means what? The every element in B is the images of some element in A. Then the given function is said to be onto. Now let f is defined from A to B be 1 1 and onto function, and f of x is equals to y for x is in A. Then the inverse function f inverse of B is defined from B to A is defined as f inverse of y is equals to x if f of x is equals to y. Now see this, the two sets, set A and the set B. That is this is the set A is a domain of f and the set B is a range of f. That is, f is defined from A to B, from x to y. And what about the f inverse? F inverse is defined from B to A. B is called the domain of f inverse and A is called the range of f inverse. We know that y is equals to f of x. Y is equals to f of x is 1 1 and onto. Then f inverse of y exists if y is equals to f of x is 1 1 and onto, then its inverse exists, f inverse of y. And if f inverse of y is differentiable, then we can find out its derivative. Now we'll take the one example. Now consider the example. F of x is equals to 2x minus 2. Then what's its f inverse? Then f inverse can be written as, that is the f inverse of x is equals to x plus 2 upon 2. Now how to find this f inverse? You can write like this also, that is the f of x is equals to 2x minus 2, and suppose that is equals to y. Now you can find out the value of x. What is that? That is a 2x is equals to y plus 2, and therefore x is equals to y plus 2 upon 2, and convert it in the variable as x. Therefore if f of x is equals to 2x minus 2, then what is f inverse? F inverse is equals to x plus 2 upon 2. And suppose that if we denote this f inverse of x, that is equals to g of x. Now we'll find out the derivative of this f of x and the g of x. Now what is the derivative of f of x? I will denote it, that is the f dash of x, the derivative of x. Derivative of f of x is denoted by f dash of x. It's a derivative. Derivative of 2x minus 2 is 2. And what is the derivative of g of x? The derivative of g of x is denoted by g dash of x. Now the derivative of x is 1, 2 is 0. That is, we will get the 1 upon 2. It's clear that the derivative of f of x is equals to 2 and the g dash of x is equals to 1 upon 2. They are reciprocal of each other. Now we will derive the rule for the derivative of the inverse function. Now we'll start the new important theorem, that is the theorem of the differentiation for the inverse function. Suppose that y is equals to f of x is a differentiable function of x, and y is 1 1 and onto, and dy by dx is not equals to 0. Also, x is equals to f inverse of y is a differentiable, then ddx of f inverse of y is equals to 1 upon f dash of x, or dx upon dy is equals to 1 upon dy by dx, where dy by dx is not equals to 0. Now we'll write the statement of this theorem. Now see this the statement. Now this start. Suppose y is equals to f of x is differentiable function of x and y is 1 1 and 1 1 and onto, and dy by dx is not equals to 0. Also, x is equals to f inverse of y is differentiable then ddx of f inverse of y is equals to 1 upon f dash of x, or dx upon dy is equals to 1 upon dy by dx, where dy by dx is not equals to 0. This is very important statement, and I will repeat it. Suppose y is equals to f of x is a differentiable function of x, and what type of that y is 1 1 and onto, dy by dx is not equals to 0. Also, x is equals to f inverse of y is differentiable function, then the ddx of f inverse of y is equals to 1 upon f dash of x, or dx upon dy is equals to 1 upon dy by dx, where dy by dx is not equals to 0. Now the proof of this theorem. We'll write the proof of this theorem. Given that y is equals to f of x and x is equals to f inverse of y are differentiable. These are the differentiable. Let delta y be increment increment in y corresponding to delta x in x, as delta x tends to 0, therefore delta y also tends to 0, as a delta x tends to 0 and therefore delta y tends to 0. Next, now we have given that y is differentiable that y is a differentiable, therefore we can write, that is y is a differentiable, limit, we can write here limit delta x tends to 0, delta y by delta x is equals to dy by dx. As y is a differentiable, therefore limit delta x tends to 0 of the delta y by delta x is equals to dy by dx. Now consider one here. Now see this here, delta y by delta x into delta x upon delta y is equals to 1. See this here, delta y by delta x into delta x upon delta y is equals to 1. Again this can be written as like this, delta x upon delta y is equals to 1 upon delta y by delta x. Now we'll take the limit on both sides, that is a delta x tends to 0. We'll take the limit on both sides for this, as a delta x tends to 0. If you write here, that is taking the limit delta x tends to 0, delta x upon delta y is equals to 1 upon limit delta x tends to 0, delta y by delta x. But y is a differentiable, therefore the limit on the RHS exists, but limit on RHS exists, therefore we can write limit delta x tends to 0, delta x upon delta y is equals to 1 upon dy by dx. Now the limit on the RHS exists, therefore limit on LHS also exists, and that as a delta x tends to 0, delta y is also tends to 0, therefore again this can be written as limit delta y tends to 0, delta x upon delta y is equals to 1 upon dy by dx, and therefore the limit of delta y tends to 0 of the delta x upon delta y is also exist, because RHS is exist. Again this can be written as, therefore this can be written as dx upon dy is equals to 1 upon dy by dx, where dy by dx is not equals to 0. And in this way you can remember this theorem. It's very simple. What is again this statement of this theorem? Suppose y is equals to f of x is a differentiable function of x and y is 1 1 and on 2. Okay, dy by dx is not equals to 0. Also x is equals to f inverse of y is a differentiable. Then we want to prove this. Dx of f inverse of y is equals to 1 upon f dash of x, or dx upon dy is equals to 1 upon dy by dx, where dy by dx is not equals to 0. What we have given? We have given that y is equals to f of x and x is equals to f inverse of y are differentiable. Let delta y be the increment in y corresponding to delta x in x. As the delta x tends to 0, delta y also tends to 0. Now y is a differentiable, therefore this can be written as limit delta y by delta x of the delta x tends to 0 is equals to dy by dx. Now consider this. It's very simple. That is that delta y by delta x into delta x upon delta y is equals to 1. Now we'll take the, again this can be written as delta x upon delta y is equals to 1 upon delta y by delta x. Taking the limit on both sides. Okay. But the limit on the RHS exists. That's we have written here. Limit on the RHS exists. Therefore, its a limit is written as 1 upon dy by dx. As a limit on the RHS exists, limit on LHS also exists, and this limit can be written as, and it can be written as delta x tends to 0, delta y tends to also 0. Therefore, the limit delta y tends to 0 of the delta x upon delta y is equals to 1 upon dy by dx. And hence the limit of this is nothing but dx upon dy is equals to 1 upon dy by dx, where the dy by dx is not equals to 0. Now we'll take the next example. Now we'll write the list of derivative of the standard inverse trigonometric function. Now the first function is sine inverse of x. Sine inverse of x, it's a derivative. Sine inverse of x is 1 upon in root of 1 minus x square, and what's here important, that is a mod of x is less than 1. Okay. Second, cos inverse of x. Cos inverse of x is equals to minus 1 upon in root of 1 minus x square. Again here the mod of x is less than 1. Next formula, third, sine cos. Now the tan inverse of x is equals to 1 upon 1 plus x square. Fourth formula, cot inverse of x. Cot inverse of x is equals to minus 1 upon 1 plus x square. And these are the important. Now the fifth one, sec inverse. Sec inverse of x is equals to 1 upon x in root of x square minus 1, and here the mod of x is greater than 1. Next is 6, cosec inverse. Cosec inverse of x, and that is equals to minus 1 upon x in root of x square minus 1, and here mod of x is again greater than 1. These are the important formulas. Sine inverse and cos inverse, you can, these are the same but they are different in sign only. Next, tan and cot, again these are the same, difference in the sign of the cot only. Sec and cosec, both of them have the same uh, formulas, but the sign is different. But how to remember all these formulas? Remember that one thing is that those functions who start with c, that is a cos start with c, next is cot with c, and the cosec c, these have the minus sign. And you can remember all these formulas in a very simple way. What you have to remember only, you have to remember only the formula of the sine inverse, tan inverse, and the sec inverse. What about the cos inverse? Negative sign. What about the cot inverse? You have to give the negative sign of the tan inverse. And what about the cosec inverse? You have to give the negative sign of the derivative of the sec inverse. In this way, you can remember. That is those trigonometry functions which starts with c, their derivatives are negative, negative. In this way, you can remember. Now again, one more list for the derivative of the inverse trigonometric functions, which these functions are the composite functions. Now the first is sine inverse of f of x. What about its a derivative? We know that derivative of sine inverse of x is 1 upon in under root of 1 minus x square. And similarly here, the derivative is 1 upon in under root of 1 minus, here is x is f of x. That is a f of x. It's a bracket square. And what's one more important thing? That is the 1 upon in under root of 1 minus f of x bracket square into the derivative of f of x. What's its a derivative? Its a derivative is f dash of x. And one more important is that again the same thing, that is a mod of f of x is less than 1. That is the sine inverse of f of x is equals to 1 upon in under root of 1 minus f of x bracket square into f dash of x. If here is a sine inverse of x, then what's its a derivative? Its a derivative is a 1 upon in under root of 1 minus x square into derivative of x. Derivative of x is 1, and therefore we write the derivative of sine inverse of x is 1 upon in under root of 1 minus x square only. But suppose that here in place of there is a one more another function. What is that? Sine inverse of e raised to x. Then what will its a derivative? Its a derivative is, that is a 1 upon in under root of 1 minus f of x, that is a e raised to x bracket square. Therefore we will write here e raised to x, it's a bracket square, into derivative of e raised to x. What's the derivative of e raised to x? Derivative of e raised to x is a e raised to x, and hence we can write it, that is a 1 minus e raised to x bracket square means what? E raised to 2x by the law of the indices. Power to the power, their multiplication of the powers, that is 1 upon in under root of 1 minus e raised to 2x into e raised to x. Derivative of e raised to x is e raised to x, and in this way we can find out the derivative of this type of the function. Now next is, these are also very simple. Second formula, cos inverse of f of x, that is equals to again minus this trigonometric function starts with the c and upon 1 minus f of x bracket square into its a derivative f dash of x, and again mod of f of x is less than 1. Next, third, tan inverse of f of x is equals to 1 upon 1 plus mod in square bracket f of x bracket square into its derivative. What's its derivative? That is the f dash of x. Okay, this is the third one. Again the tan inverse. Tan inverse of f of x is equals to 1 upon 1 plus f of x bracket square into its derivative. What about the next? Fourth one, that is the cot inverse of f of x is equals to minus 1 upon 1 plus again f of x bracket square into f dash of x. Okay, into f dash of x. That is the cot inverse of f of x minus 1 upon 1 plus f of x bracket square into its a derivative. Derivative of f of x is a f dash of x. Next, fifth one, derivative of sec inverse of f of x. Again, that is a 1 upon f of x in root of f of x bracket square minus 1. Okay, into again the derivative of f of x is the f dash of x. This is sec inverse. And the next is sixth is cosec inverse. I will write here cosec inverse of f of x is equals to, again here I will write here minus. One more thing is that here the mod of f of x is greater than 1. We have written for the sec inverse of x and cosec inverse of x. At that time mod of x was greater than 1. Similar here f of x, mod of f of x is greater than 1, and here is a cosec inverse of f of x is minus 1 upon f of x in root of f of x bracket square minus 1 into its a derivative f dash of x, where again the mod of f of x is greater than 1. In this way you can remember all these results, that is a function and its a derivative. This is the composite type of the trigonometric function. It's sine inverse of f of x and there is not x. When there is f of x, that function may be different types of function. They may be exponential, algebraic. Okay, they may be also trigonometry. Okay, and you can remember all these. Again, one thing is that those are trigonometry function we start from the C, they have the negative, again the negative, again the negative. Only here x is replaced by f of x. Okay, now in this way you can remember all these trigonometric derivatives. You can remember all these derivatives of the inverse trigonometric functions. Now we'll take the next important formulas. This is also important list of the formulas when you will solve the derivatives of the inverse trigonometric function. Now see this here. This is also very simple. What is that? Sine inverse of sine theta, and that's equals to theta. Sine inverse of sine theta, that's equals to theta. What about the next? Sine inverse of theta, that is equals to also theta. Next is cos inverse of cos of theta, that is equals to theta. Here again the cos inverse of theta, that is also theta. Next, tan inverse of tan of theta, that is equals to theta. And here again the tan inverse of theta, that is also theta. Okay, next is sec inverse of sec of theta, that is theta. And here the sec inverse of theta, that is also theta. Next is cosec inverse of cosec theta, and that is equals to theta. And here again the cosec of cosec inverse of theta, and that is equals to theta. Next formula is, what is that? Cot inverse. Okay, have completed the tan, that is the cot inverse of cot of theta, and that's equals to theta. And here again the cot inverse of theta, and that's equals to theta. You can remember all these very simple. Sin inverse of sin theta is theta, and similarly sin of sin inverse of theta is also theta. If you remember only this line, you can remember all these formulas also. No difference is there. Okay, now we'll take the next type of the formulas. Now this is also very important list. See this here. Sin inverse of cos of theta, that is equals to sin inverse of. Now this cos theta will convert. Cos of theta is equals to sin of pi by 2 minus theta, and I will write here sin of pi by 2 minus theta. And now our previous list, that is sin inverse of sin theta, that is equals to theta, and similarly here that is equals to pi by 2 minus theta. This is the first one. What about the second? Now here sin and the cos, I will take here cos inverse of, now cos inverse of sin theta. Again this theta can be written as, that is the in terms of cos, sin theta can be written in terms of the cos, that is the cos inverse of cos of pi by 2 minus theta, and that is equals to pi by 2 minus theta. Cos inverse of cos theta, that is equals to pi by 2 minus theta. Sin cos, the relation between sin and cos, tan and cot, sec and cosec. You can remember this, remember like this: sin and cos, tan and cot, sec and cosec. Therefore next is tan inverse of cot of theta, and that's equals to here tan inverse of, this cot can be converted into the tan, and it is written as like this, that is the tan of pi by 2 minus theta, and this equals to tan inverse of tan of theta, that is pi by 2 minus theta. Next is cot inverse of tan of theta. Again convert this tan theta in terms of the cot. I can write here that is the cot inverse of cot of pi by 2 minus theta, and that's equals to again pi by 2 minus theta, again the cot inverse of cot, that is pi by 2 minus theta. Next is sec inverse of cosec theta. Again sec inverse, this cosec can be converted into the sec. This is the sec of pi by 2 minus theta, and that's equals to pi by 2 minus theta. The next result is cosec inverse of sec theta. Again we will convert this sec theta in terms of cosec, that is the cosec inverse of, convert this sec in terms of cosec pi by 2 minus theta, and that is equals to pi by 2 minus theta. Again see this, all the answer is pi by 2 minus theta, but when sine inverse of cos theta is pi by 2 minus theta, cos inverse of sine theta is again pi by 2 minus theta, tan inverse of cot theta is pi by 2 minus theta, and in this way you can remember all these results. These results are very important to solve the problem. Now we'll take the next list. Now this is also very important list. What is that? Sine inverse of minus x, that's equals to minus sine inverse of x. You know that the sine of minus theta is equals to minus sine theta. You can remember in this way also. Next is tan inverse of minus x is equals to minus tan inverse of x. But now this is very important, that is cos inverse of minus x is equals to pi minus cos inverse of x. Many times the student forget for this. Okay, that is the cos inverse of minus x is equals to pi minus cos inverse of x. These are also very important list to solve the derivative of inverse trigonometric function. Now the next list. Now this is also very important list. Now here one upon x is equals to cosec inverse of x, cos inverse of 1 upon x is equals to sec inverse of x, their reciprocals. Tan inverse of 1 upon x is equals to cot inverse of x. Next is cot inverse of 1 upon x, then it is tan inverse of x. It's very easy to remember. And cosec inverse of 1 upon x, that is equals to sine inverse of x. Next, sec inverse of 1 upon x is equals to cos inverse of x, and in this way you can remember all these type of the formulas. Now again, very important thing is that the see the relation between the sine inverse and cos inverse. Now again one more list. Sine inverse of x plus cos inverse of x is equals to pi by 2, the relation between the sine inverse and the cos inverse. Next is tan inverse of x plus cot inverse of x, and that is equals to also pi by 2. This is also relation between the tan and cot. And the last is sec inverse of x plus cosec inverse of x, and that is equals to also pi by 2. This is also very important result to solve the derivative of the inverse trigonometric functions problem. Sine inverse of x plus cos inverse of x is equals to pi by 2. Tan inverse of x plus cot inverse of x is equals to pi by 2. Sec inverse of x plus cosec inverse of x is equals to pi by 2. Now the next formula is, that is a tan inverse of in bracket x plus y upon 1 minus x into y, and that's equals to tan inverse of x plus tan inverse of y. And the next is tan inverse of in bracket x minus y upon 1 plus x into y, and that's equals to tan inverse of x minus tan inverse of y. This also important results to solve the problems. Now we'll start the exercise and solve the problems of the derivative of the inverse functions. Hello friends, now we will start the examples. Find the derivative of the function y is equals to f of x using the derivative of inverse function x is equals to f inverse of y in the following. Now the first example, I will take the alternate example. The first example is y is equals to root x. We want to find out the derivative, that is y is equals to f of x, with the help of the inverse. Here we want to express x in terms of the y. Now the solution here, y is equals to root x. Okay, that is we have to apply the formula dy by dx is equals to 1 upon dx upon dy. Therefore, here we will express x in terms of y. Now squaring on both sides, then you will get y square is equals to x. Okay, therefore x is equals to y square. Okay, now x is function of y. Here y is a variable. Now we will differentiate this with respect to y. Therefore, differentiate with respect to y. Therefore, you will get dx upon dy is equals to 2y. Now substitute the value of y. What is the y? Y is equals to root x. That is a 2 root x, because we want the answer in terms of x. What is our formula? That is the dy by dx is equals to 1 upon dx upon dy. Now substitute the value of dx upon dy. The value of dx upon dy is 2 root x. Therefore, dy by dx is equals to 1 upon 2 times root x, and this is the answer. Okay. Now once again, see this y is equals to root x, squaring on both sides, differentiate. X is a function of y, differentiate this with respect to y, dx upon dy, derivative of y square is a 2y. Substitute the value of y is equals to root x. But what is our formula? That is the dy by dx is equals to 1 upon dx upon dy, and substitute its value. What is the dx upon dy? That is the 2 root x, and this is the answer. Now we'll take the next example. Now next, the problem is y is equals to cubic root of x minus 2. We want to find out the inverse function of y is equals to f of x. Means express x in terms of y. It's very simple. Again, that is the y is equals to cubic root of x minus 2. Now take cube on both sides. Then you will get here y cube is equals to x minus 2, and therefore x is equals to y cube plus 2. Now here it's like this, x is equals to f inverse of y. Now differentiate this with respect to y. Differentiate this. What is the dx upon dy? Dx upon dy is equals to derivative of y cube. It's very simple. That is a 3y square, and derivative of 2 is 0. It's a constant. Now express this y in terms of x. Therefore, I will write here that is a 3. What is y here? Y is a cubic root of, here y is a cubic root of x minus 2, and it's a bracket square. Overall, we can write this, that is 3, and this is the cubic root of square. Therefore, we can write here x minus 2 raised to 2 upon 3, and here this is the dx upon dy. Now what is our formula? That is the dy by dx is equals to 1 upon dx upon dy, and therefore we will write here that is the dy by dx is equals to 1 upon dx upon dy, and substitute the value. Therefore you will get here, what is the value of dx upon dy? Dx upon dy is 3 in bracket x minus 2 and bracket raised to 2 by 3, and hence the answer is, that is a dy by dx is equals to 1 upon 3 into, in bracket, x minus 2 bracket raised to 2 upon 3, and this is the answer. Okay, now we'll take the next example. Now the next problem is y is equals to 2x plus 3. It's a solution. Again we will express, that is we will find out the inverse function of y is equals to f of x. It means express x in terms of y. Here y is equals to 2x plus 3, and therefore we can write here y minus 3 is equals to 2x, and therefore x is equals to y minus 3 upon 2. Now again differentiate this with respect to y. Therefore here y is a variable, therefore we will write here differentiate this with respect to y. Therefore, dx upon dy is equals to, what's the derivative of y? Is 1. Derivative of 3 is 0. That is, you will get here 1 upon 2. And what is our formula? Our formula is dy by, we want to find out dy by dx. Dy by dx is equals to 1 upon dx upon and dy. And therefore, dx upon dy is 1 upon 2. And here 1 upon 2. And its a reciprocal is 2. And therefore, dy by dx is equals to 2. And this is the answer. Now you can see this also. Now we'll take the next example. Now the next question is y is equals to e raised to 2x minus 3. I am taking the all odd type of the examples in this series, and when there is a next series I will take the even type of example. Okay, y is equals to e raised to 2x minus 3. Again we will find out the inverse function of y is equals to f of x. It's very simple. That is, y is equals to, see this here, e raised to 2x minus 3. Now this is in the form of the exponential. We'll express in terms of the logarithmic. That is, you can take log on both sides also, and it's very simple. When this e comes on this left hand side, it becomes logarithmic. Or you can take log on both sides and you will get directly taking log on both sides. Take log on both sides, because we want to express x, we want to express y, we want to express x in terms of y. Therefore, this is the log of y is equals to, now log of e raised to 2x minus 3, but there is a b, e is the base, therefore here you will get 2x minus 3. Again I will explain here, as there is the e is the base, and if you take here 2x minus 3, and overall this exponent part comes here and it will written as 2x minus 3 log of e to the base e, and log of e to the base e is 1, and therefore we have here 2x minus 3. We want to express x in terms of y, and therefore I will write here, that is the log of y plus 3 is equals to 2x, and therefore x is equals to log of y plus 3 upon 2. Now here x is in the form of the y. This is the inverse function of y is equals to f of x. Now differentiate this with respect to y. I will write here, differentiate with respect to y. Therefore you will get dx upon dy is equals to, what is the derivative of y? Log of y. Derivative of log of y is a 1 upon y, and therefore I will write here 1 upon y. Derivative of 3 is 0. Okay, and this is the denominator, and overall you will get 1 upon 2y. Okay, the value of y is e raised to 2x minus 3, and hence I will write here, that is a 2 into e raised to 2x minus 3, and therefore you will get here, that is the dx upon dy is equals to 1 upon 2 e raised to 2x minus 3. Okay, and hence what is our dy by dx? Here dy by dx is equals to 1 upon dx upon dy, 1 upon dx upon and dy, and that's why here the value of dx upon dy is, that is 1 upon again 2 into e raised to 2x minus 3, and overall again this can be written as, that is a 2 e raised to 2x minus 3, and hence the answer is, I will write here answer, therefore dy by dx, okay, dy by dx is equals to, dy by dx is equals to 2 e raised to 2x minus 3, and this is the answer. Okay, now we'll take the next example. Now this question is also very interesting. Find the derivative of the inverse function of the following. What's the function y is equals to x square into e raised to x? What was in the previous question? In previous question we want to differentiate y is equals to f of x using x is equals to f inverse of y, and here we want to find out only the derivative of the inverse function of the following. Now what is the formula here? The formula is, that is a dx upon dy is equals to 1 upon dy by dx. This is our formula. In previous we apply the formula, that is a dy by dx is equals to 1 upon dx upon dy. Here we are applying this formula. We want to find out the derivative of the inverse of the function. Now what is the, here y is equals to x square into e raised to x. Now differentiate this, very simple, differentiate with respect to x, and therefore dy by dx is equals to, apply here the product rule. What is here? Keep x square as it is, the derivative of e raised to x is e raised to x, plus find out the derivative of x square. The derivative of x square is 2x and e raised to x is as it is. Now from this we will take the common as a x into e raised to x as a common, x into e raised to x as a common, then in bracket you will get x plus here 2, x plus 2, x into e raised to x, in bracket x plus 2, and this is our dy by dx. Therefore dy by dx is equals to x into e raised to x, x plus 2. But we want to find out dx upon inverse, derivative of the inverse of the function. What's our formula? Our formula is, that is a dx upon, I will write here, dx upon dy is equals to 1 upon dy by dx. What is our dy by dx? Our dy by dx is x into e raised to x, in bracket x plus 2, and this is the answer. This is the derivative of the inverse of the function y is equals to x square into e raised to x. I will take the next question. Now again the next question, y is equals to x into 7 raised to x. Again here differentiate this with respect to x. Therefore, dy by dx is equals to here x into 7 raised to x. The product of the two functions, we will apply here the product rule. Derivative of x is 1 and derivative of 7 raised to x is 7 raised to x into log of 7. Here we will apply the product rule. Keep this 7 raised to x first of all as it is. Find out the derivative of x is 1 into 7 raised to x. Next, x and the derivative of 7 raised to x. 7 raised to x into log of 7. Now from this we will take 7 raised to x as a common. Then you will get here in bracket 1 plus x into log of 7. This is dy by dx. But we want to find out the derivative of the inverse of this function. Therefore, what is our formula? That is a dx upon dy is equals to 1 upon dy by dx, and hence here 1 upon 7 raised to x in bracket 1 plus x log of 7, and bracket is complete, and hence the answer dx upon dy is equals to 1 upon 7 raised to x in bracket 1 plus x log of 7. Here that is a dx upon dy is equals to 1 upon 7 raised to x into in bracket 1 plus x log of 7. Now this is the answer. Now we'll take the next example. Now the next question is again very simple. Y is equals to x log x. Again differentiate this with respect to x. Therefore, dy by dx is equals to, here we will apply again the product rule. Derivative of log of x is 1 upon x. Derivative of x is 1. First keep x as it is, and the derivative of log of x is 1 upon x plus derivative of x is 1 into here the log of x. Now here x get cancelled. You will get here 1 plus log of x, and this is the dy by dx, and therefore dx upon, by the formula we want to find out the derivative of the inverse of this function. Therefore dx upon dy is equals to dy by dx, and that's equals to 1 upon 1 plus log x, and hence dx upon dy is equals to 1 upon 1 plus log x, and this is the answer. I have taken all the odd type of the examples. Now we'll take the next question. Now the next question is, find the derivative of the inverse of the function and also find their value at the point. Same type of the problems, that is here we'll apply the formula, that is dx upon dy is equals to 1 upon dy by dx. This type of problems we have solved in previous question. One more thing is that we want to find out its value at x is equals to 1. Now again y is equals to x raised to 5 plus 2x cube plus 3x. Now differentiate this. Differentiate with respect to x. Therefore, dy by dx is equals to derivative of x raised to 5. That is 5x raised to 4. What about the derivative of x cube? 2 is a multiplicative constant. Derivative of x cube is a 3x square. But the 3 into 2, it will become 6. Here I am write 6x square. And the derivative of 3x, 3 is a constant, and the derivative of x is 1. 3 into 1, that is 3. And hence, by the formula, that is dy by, dx upon dy, dx upon dy, that is equals to 1 upon dy by dx. And this can be written as, that is the dy by, dx upon dy is equals to 1 upon, what about the dy by dx? Dy by dx is 5x raised to 4, 5x raised to 4 plus 6x square plus 3. Okay. Now we want to find out its a derivative at x is equals to 1. We have to substitute here x is equals to 1. Therefore, dx upon dy at x is equals to 1, and that is equals to 5. The value of x is 1 raised to 4 plus 6, 1 square plus 3, and overall if you simplify this, then you get 5 plus 6 plus 3, that is 5 plus 6, 11, 11 plus 3, and that is equals to 14. And hence the dx upon dy at x is equals to 1 is 1 upon 14. Okay, and see this here. This is the answer. Now we'll take the next problem. Now the next problem is y is equals to 3x square plus 2 log of x cube. And now see this again here. Y is equals to 3x square plus 2 log of x cube. I will here apply the rules of the logarithm. That is log of x raised to m is equals to m into log of x, and therefore again this can be written as, that is a 3x square plus 3 into 2, then you will get here 6 log of x. That is, I have applied the rule here, log of x raised to m is equals to m times log of x. Now differentiate this with respect to x. Differentiate with respect to x, and therefore dy by dx is equals to derivative of 3x square, that is the 6x, and the derivative of log of x is 1 upon x. It means 6 upon x. And now by the definition of the derivative of the inverse function, dx upon dy is equals to, dx upon dy is equals to 1 upon dy by dx, and the value of dy by dx is 1 upon 6x plus 6 upon x, and we want to find out its a value at x is equals to 1. Here at x is equals to 1. Therefore the dx upon dy, substitute x is equals to 1, that is 1 upon 6 into 1, that is 6, 6 upon 1, that is also 6, 6 plus 6, that is a 12, and therefore the dy by dx here, sorry, dx upon dy is equals to 1 upon 12, and this is the answer. I will take the next question. Now the next question, if f of x is equals to x cube plus x minus 2, find f inverse of, it's a derivative, f inverse of dash at y is equals to minus 2. That is the value of the y is minus 2. We have to apply here the, we want to find out here dx upon dy. See this here? We want to find out dx upon dy, that is equals to 1 upon dy by dx. And we have given the value of y is minus 2. I had changed the problem here, modified this question. Instead of 0, I had taken minus 2. That is, we want to find out dx upon dy, that's equals to 1 upon dy by dx. But we will require the value of x here. Now see this function y is equals to, what is y is equals to? F of x is equals to x cube plus x minus 2. Here the value of y is minus 2. Then what will be the value of x? The value of x must be 0. X must be 0. Now the problem is very easy. Okay. Now see this here. We want to find out first of all, it's a derivative. That is here y is equals to x cube plus x minus 2. Now differentiate this with respect to x. Differentiate with respect to x. Therefore, dy by dx is equals to derivative of x cube. Derivative of x cube is 3x square and x is 1, 2 is 0. And the derivative of, again, it's a value, dy by dx at x is equals to 0 is, that is 3 into 0 plus 1, and that is equals to 1. Therefore, dy by dx at x is equals to 0 is 1. Now what is our formula? Our formula is, we want to find out, that is a f inverse of, it's a derivative at y is equals to minus 2. And what is its formula? What is its formula? That is a f dash of x at x is equals to 0. It means dy by dx, that is 1 upon dy by dx at x is equals to 0, and its value is 1 upon 1, and hence the f inverse of, it's a dash at minus 2 is equals to 1, and hence the answer is, one thing is that we want to find out the derivative of the inverse function, and the formula is this. Simply we want to find out the dy by dx and also the value of x. Value of x is 0 when y is minus 2, and hence the answer is 1. Now we'll take the next question. Now the next question, using the derivative, prove that tan inverse of x plus cot inverse of x is equals to pi by 2. Now here, let, we'll write here, let f of x is equals to tan inverse of x plus cot inverse of x. Cot inverse of x. And suppose that equals to k. Okay. Now we'll differentiate this, that is differentiate this with respect to x. What's the derivative of f dash of x is equals to? Derivative of tan inverse of x, that is equals to 1 upon 1 plus x square, and derivative of cot inverse of x is minus sign. It has a minus sign, that is a minus 1 upon 1 plus x square. It means that is 1 upon 1 plus x square minus 1 upon 1 plus x square, that's equals to 0. It's a derivative f dash of x is equals to 0. Now the derivative of this f of x is 0, then the given function must be constant. Therefore, we will write here, let f of x is equals to k, and therefore we will write here, that is a tan inverse of x plus cot inverse of x is equals to k. And suppose that we will take here the value, suppose at x is equals to 0. What's happening here? At x is equals to 0, that if put x is equals to 0 here, then you will get tan inverse of 0 plus cot inverse of 0, and that's equals to k. But what is the tan inverse of 0? Tan inverse of 0 is 0. Okay, it's a 0. And what about the cot inverse of 0? It's a pi by 2, and that's equals to k. And therefore here we have, that is a k is equals to pi by 2. But what is the k is equals to? At the starting we have written, that is the f of x is equals to tan inverse of x plus cot inverse of x is equals to k is equals to pi by 2, and hence we have proved that the tan inverse of x plus cot inverse of x is equals to pi by 2. In this way we can prove. It's very simple. The given function is k, differentiate it, it's a derivative 0. As it's a derivative 0, we consider here that's equals to k, but tan inverse of x plus cot inverse of x is equals to k. At x is equals to 0, tan inverse of 0 is 0, cot inverse of 0 is pi by 2. That's nothing but the k. K is pi by 2, and hence the answer. Now we'll take the next question. Now this is very simple question. Differentiate this with respect to x. Now let y is equals to tan inverse of log of x. Now differentiate this with respect to x. Therefore, dy by dx is equals to 1 upon, what is the derivative of tan inverse of x? That is 1 upon 1 plus x square. And here x is log of x. That is a log of x bracket square into ddx of log of x. What's the derivative of log of x? The derivative of log of x is 1 upon x, and hence the answer dy by dx is equals to 1 upon x in bracket 1 plus log of x bracket square, and this is the answer. Okay, this is the answer. Now we will take the next problem. Now see this here, y is equals to cot inverse of x cube. Again the same dialogue here. Differentiate with respect to x. The derivative of cot inverse of x is minus 1 upon 1 plus x square, and here again the dy by dx is equals to minus 1 upon, but what is x here? X is x cube. Therefore 1 minus 1 upon 1 plus x cube, and it's a bracket square into ddx of x cube. Okay, now here that is a minus 1 upon 1 plus x cube bracket square, that is 1 plus x raised to 6. What is the derivative of x cube? The derivative of x cube is a 3x square, and overall you will get here minus 3x square upon 1 plus x raised to 6, and this is dy by dx, and therefore the derivative of y is equals to cot inverse of x cube is equals to, that is a dy by dx is equals to minus 3x square upon 1 plus x raised to 6. Now we'll take the next problem. Now here the problem is tan inverse of root x. Again, let y is equals to tan inverse of root x. Again, differentiate this with respect to x. Okay, differentiate with respect to x. Therefore, dy by dx is equals to, what is the derivative of tan inverse of x? Is 1 upon 1 plus x square, but here root x. Therefore, I will write here that is a 1 upon 1 plus root x bracket square into ddx of root x, derivative of root x. What is the derivative of root x? That is a 1 upon 2 times root x, that you have learned in 11th standard. That is 1 upon 1 plus root x bracket square means what? 1 upon 1 plus x. What is the derivative of root x? Derivative of root x is 1 upon 2 root x, and therefore we can write here that is a 2 root x in bracket 1 plus x, and this is the dy by dx. Therefore the its derivative is dy by dx is equals to 1 upon 2 root x in bracket 1 plus x. Now we will take the next problem. Now here is the problem. Let y is equals to cos inverse of, in bracket, 1 minus x square. We know the derivative of cos inverse of x. That is the derivative of cos inverse of x is minus 1 upon in under root of 1 minus x square. And similarly here, that is a differentiate again with respect to x, and therefore dy by dx is equals to minus 1 upon in root of whatever that here, it's a square, that is a 1 minus x square, and it's a bracket square into ddx of 1 minus x square. Okay, and that's equals to minus 1 upon in root of, okay, 1 minus square of this 1 minus x square, and it's a bracket square, that is first is 1 square minus 2 x square plus square of this is x raised to 4, okay, into the derivative of 1 is 0, x square is a minus 2, therefore it is a minus 2x. If we simplify this, here is a plus 1 and minus 1 that get cancelled, and remaining has the sign plus 2x square minus x raised to 4, and therefore I will write here minus and minus that will become plus. Here is a 2x upon in root of plus 1 and minus 1 get cancelled, you will get here 2x square minus x raised to 4. Now from this we can take x square as a common. If we take x square as a common, but here root sign, that x square will become x here, and hence I will write here series here 2x upon, if I take x square as a common and root of x square is x, therefore I will write here x in root of x square as common, then in bracket you will get 2 minus x square. If I take the x square as a common, then in bracket you will get 2 minus x raised to 2, and the root of x square is x. Now here this x and x will get cancelled, and you will get 2 upon in root of 2 minus x square, and that's why the dy by dx is equals to 2 upon in root of 2 minus x square, and this is the derivative. Dy by dx is equals to 2 upon in root of 2 minus x square. Now we'll take the next problem. Now the next problem is also very interesting. That is the cos inverse of cos cube of cos inverse of x cube. Now here let y is equals to cos cube of cos inverse of x cube, and again this can be written as, that is a cos of, in bracket, cos inverse of x cube, and it's a bracket cube. Now cos of cos inverse of theta is theta, but here is again this is nothing but the x cube, and it's a bracket raised to 3. Cos of cos inverse of theta is theta, and here that is y is equals to, and therefore 3 raised to 3, that is power raised to power, the power multiplication, that is x raised to 9. Now here y is equals to x raised to 9. Now differentiate this with respect to x, and therefore dy by dx is equals to 9 x raised to 8. Okay, and this is the answer. That is the dy by dx is equals to 9 into x raised to 8, and in this way we have completed up to the question number 6. Now the remaining question will be in my next video. Till then, goodbye.